Kamiak Butte, named after the Yakima Nation chieftain, stands as a prominent landmark in the region of eastern Washington known as the Palouse. This area is famous for its rolling hills covered with wheat that stretches across the landscape, making Kamiak Butte an outlier with its dense canopy of pine trees and tangled understory brush. What is it that makes Kamiak Butte so unique from the rest of the Palouse? To tell the full story of how the butte came to be, we must go back to when the Palouse was at the bottom of the ocean 200 million years ago. This was the time when the supercontinent Pangaea began to rift apart, opening the Atlantic Ocean basin while closing the Pacific Ocean basin, a process that continues to this day. When the North American plate first began to drift to the west, the modern western coast formed from subducting the denser ocean plate beneath it, and from the accretion of volcanic island arcs. These subduction and accretion events continued for 150 million years until it eventually led to the deposition of quartzite sand, which finally rose above the sea 50 million years ago. The quartzite sand would continue to rise for another 33 million years, ending 17 million years ago, until unique volcano eruptions originating from continental hotspots flooded the majority of eastern Washington with a dense dark rock called basalt. This basaltic flooding would continue for another 11 million years, ending 6 million years ago. The basaltic floods covered the landscape of eastern Washington in what is now known as the Columbia River Basalt Group. However, Kamiak Butte was not completely covered by these basaltic floods, which would later become one of the reasons for its uniqueness. The final layer of soil that covers the Palouse and Kamiak Butte are the loess soils that make the region so fertile. These soils were created during the ending of our latest ice age and the Missoula floods that accompanied them. These series of floods crashed through the channeled scablands, stripping trees and rocks from the landscape until they flowed into the Columbia. Here, all of that debris was eventually bottlenecked by the Wallula Gap. The crushed debris was deposited in the now slow-moving waters, and when the soil was exposed to the surface, the heavy winds of the Columbia River Gorge would carry the lightweight soil to be deposited to the east in the Palouse. Loess soil, on top of basalt, on top of quartzite. These are the layers that make up the foundations of the Palouse. The fertile loess soil works in tandem with the water-retaining basalt underneath that makes the Palouse the nation's leading producer of wheat. But remember that Kamiak Butte was not completely covered by the basaltic floods millions of years ago. Kamiak Butte is instead layered with loess soil and quartzite sands below. The quartzite allows more water to pass through it, like a strainer. This makes it difficult to grow the more shallow-rooted wheat on the butte. Yet the deep tap roots of pines and shrubs are able to endure and prosper on the butte. These geological foundations are what makes the butte such a unique landmark in the fields of wheat. When we look at Kamiak Butte from above, we can see that there are more trees on one side of the butte, called an aspect, than the other aspect. Does this have to do with the geology I explained earlier? It's a good guess, but both aspects have the same geological foundations underneath, so this is not the case. You may be familiar with a concept known as the rain-shadow effect, or orographic lift, in which a weather system that originates in the Pacific Ocean makes landfall and comes into contact with mountains. This causes the weather system to rise above the mountains, cooling as it does so, and loses its moisture as rain or snow, leaving one aspect of the mountain wet on one side, allowing more plants to grow, and dry on the other side, allowing less plants to grow. This is what happens to the west of the butte in the Cascade Mountains that run north to south along Washington state. This seems like a perfect fit, but this theory breaks down when data shows that both aspects of Kamiak Butte receive the same amount of precipitation, and that the crest of the butte runs from east to west, not north to south like the Cascades. The difference in the density of trees is actually attributed to sunlight. Being in the northern hemisphere, the tilt of the Earth orients it so that the sun is in the southern part of the sky for the majority of the year. This means the south side of the aspect is bombarded with more solar radiation, drying the soils and making it so only the hardiest of trees and shrubs can grow. While the northern aspect is more shielded from the direct sunlight, the soils remain more damp, allowing more diverse and abundance of plants to grow. The species of plants that can grow in an area is dependent on the climate, which makes up the precipitation, temperature, and solar radiation. The three tree species that are able to thrive on Kamiak Butte are the Douglas fir, western larch, and ponderosa pine, the latter of the three being the most drought tolerant, and the only one able to survive on both aspects of the butte. The drier southern aspect is just too rugged for the Douglas fir and western larch. Using plot data from both aspects, we can actually calculate the estimated number of trees per acre on both aspects, with the number of trees on the south aspect to be around 35, while the number of trees on the north aspect is close to 130. This means that there are approximately 3 times the amount of trees on the northern aspect than the southern aspect. These trees provide shelter and food for wildlife such as deer, elk, and moose. The coyotes and even signs of cougars have been observed as well. But this island of trees in the agricultural field landscape also offers a reprise for a variety of raptor species. Hawks, such as the red-tailed and Swainson's hawk, can be seen patrolling the skies during the day in the spring and summer months, while the northern harrier is around all year, but especially prominent during the winter. At night, the great horned owl will perch on top of the trees, awaiting for unsuspecting prey, while the barn owl prefers to silently glide through the skies in search of their next meal. The unique geology that shapes how Kamiak Butte interacts with the local climate gives rise to the unique land feature that we see on the Palouse today, enjoyed by both humans and wildlife today and for generations to come.